Let's take a look at example 2. Consider the following sets. Set A is equal to the set of natural numbers less than 20 that are divisible by 3. Set B is equal to the set of natural numbers less than 20 that are divisible by 5. Let's start by listing the elements of each set. So set A, numbers less than 20, divisible by 3. So these are the numbers that are multiples of 3, 3, 6, 9, 12, 15, and 18. For set B, these will be the multiples of 5, 5, 10, 15. We do not include 20 because 20 is not actually less than 20. The next set is the complement of A, so A prime equals, so these would be the numbers that are not multiples of 3. 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. For B, write a description of the elements of the complement of set B in words. So since B is the natural numbers that are divisible by 5, we could say that the complement is the natural numbers less than 20 that are not divisible by 5. I'm going to look at another set, a third set, C, which is the set of natural numbers less than 20 and multiples of 6. So let's first of all, what would this set look like? So we're talking about the multiples of 6. So 6, 12, and 18. We have 3 elements. Now, would C be a subset of A? Well, we look at each element in C, and we see that 6 is an element of A, 12 is an element of A, and 18 is an element of A. So indeed, C is a subset of A. That's true. For the second one, let's take a look at the elements of C and see if they are in B. So right away we see that the 6 in set C is not in set B. So C is not a subset of B. So we can see that C is not a subset of B is true. And then we have A prime, subset of C prime. And if we look at the A prime, 1, 2, 4, 5, etc., none of those elements would actually be in, all of those elements would actually be in C prime, so that would indeed be true. Intersection of sets and union of sets. We will use the sets from a previous example to introduce more terminology used in set theory. Recall set E 0, 2, 4, 6, 8, set L 0, 1, 2, 3, 4, 5, and 6, and set O 1, 3, and 5. Intersection of sets. The intersection of set A and set B is set called A and B and is denoted by A intersect B. The intersect symbol is like an upside down U. It is the set of elements that are members of both set A and B. For example, the intersection of sets E and L would be E intersect L equals 0, 2, 4, and 6. Notice those 4 elements are in both E and in L. Union of sets. The union of set A and set B is a set called A or B and is denoted by A union B. The union symbol looks like a U. It is the set of elements that are members of either set A or set B or both. The union of sets E and L would be E union L equals 0, 1, 2, 3, 4, 5, 6, and 8. Each of those members of that union would be either exist in set E or in set L or would exist in both. Disjoint sets. Two sets are said to be disjoint if they have no elements in common, i.e., the intersection of the two sets is the empty set. For example, the set of 2, 3, and 4 and 5, 6, and 7 are disjoint because if we were looking for the intersect of these sets, there would be no elements there, so that would be the empty set, and they have no elements in common. In this case, we see that set E and set O are disjoint. Example 3. Consider the sets A, B, and C from the previous example, where in the universal set would be the natural numbers less than 20. Recall that A, we're going to talk about the numbers that are divisible by 3. Set B will be the numbers that are divisible by 5. And C are the numbers that are multiples of 6. We are going to put these numbers into a Venn diagram just so that we can see the relationships easily. Remember that the universal set is represented by the rectangle. Set A, B, and C are all represented by the circles. The numbers that are divisible by 3 are contained entirely in set A. So we've got the 3, 6, 9, 12, 15, and 18. The numbers that are divisible by 5 are contained in set B. So that's the 5, the 10, and the 15. And the numbers that are multiples of 6 are contained in the subset C, 6, 12, and 18. And notice that this set lies entirely within set A. Let's start with A intersect B. So that would be the area that overlaps between A and B, which contains the element 15. A union B will contain all the elements that are in set A and set B. So that would include your 3, 5, 6, 9, 10, 12, 15, and 18. A prime intersect B. So that would be all the elements that are not in A and are in B. So this would be just the elements 5 and 10. Now, the last two are quite complicated, so you might want to just take a moment and really study this to see if you can see the relationship. We are going to start with the brackets. So what we have here is A intersect, and then in the brackets we have B union C. So the first thing we would do is look at what B union C would be, and that would be the 5, the 6, 12, 10, 15, 18. And we just want to know where those intersect with A. And in fact, that would be the numbers 6, 12, 15, and 18. We will discover that if we move the brackets to the first two sets instead of the last two sets, and we have bracket A intersect B, close bracket, union C, we're going to end up with the exact same 4 elements. Again, just take a moment and see if you can see these relationships.